Welcome to Pavitra Laptop Care. Mr. Chandra, today you want to know the dual battery working concept, right?
Yes, sir.
So then we will discuss how this dual battery will work. Because till now I have seen only one battery, how it will work completely, you know that, yeah, you gain the knowledge.
Yes, sir.
But using these two batteries, how ThinkPad will work, what are the concept and what are the secrets. Today we will discuss entire things, okay?
Okay.
Using the schematic, so we will discuss. Here this one is ThinkPad, Lenovo ThinkPad T460S, correct? It's a slim model. So what is the model number? It's NMA421. So it has some issues that one you are going to rectify. But the thing is, you want to know before this, right?
Yes, sir.
Okay. Anyway, so let us start. Mr. Chandra, see, the main concept is the motherboard should get the source, correct? Source maybe comes from type C or maybe adapter or maybe battery or multiple of batteries or multiple of adapters. These are called as a source, but finally it will reach to charging IC, correct? As a one source. Either it may be battery source or it may be type C or adapter source, whatever it may be. We can put type C more than 1 or more than 10 or more than 100, whatever it may be. But finally only one voltage, which one is higher than previous one or before one, whatever it may be, higher voltage will enter to the charging IC. That truth you know already. You already practice much boards, so you know that, right? So now you want to know the dual battery concept. So you already saw the type C and normal adapter, how it will come to in a one source, single source, and it will enter to the charging IC. So now dual battery, how it will come and how it will give the continuous power supply to the motherboard, that we will discuss. Okay, see, now it's a what is that, Lenovo ThinkPad T460S schematic, correct? Its a manufacturer name is Lenovo. Lenovo is the manufacturer. Its date is December 15, 2015. So now where we have to go? First we will go to DC in. First we can understand the adapter section. Next we will move to battery section. In these two will active. Now once you give the supply, what are the ICs will get active? Those things we will discuss. Okay, one by one completely I will explain. See, the DC in is 69. So we need to go to 69 page number. Okay, this is the DC in section. DC in. How many pins are there total?
7 pins.
7 pins. So number 5 is the adapter ID. So in Dell and HP you have seen the adapter ID. In Lenovo also adapter ID is there. Depending on that only wattage information goes to IO. That 120 or 90 watt or 65 watt or 45 watt, whatever it may be, that information goes to IO. So now here is the ACDC underscore ID. In Dell, what will be the ID?
PSID.
Name PSID, right? In HP, AD underscore ID. In Toshiba also AD something will come. So here in ThinkPad series, ACDC underscore ID has come. So where it's going? It's going to 57 and 59. So how it will go and where it will go, that we will check. See, first we need to copy this and we need to search. See, it's coming from the dock station also. See, this is the dock station. It means in in professional laptops, there will be two sources. One is from dock and one is from directly adapter side. Okay, DC inside. So here from dock side also AC ID, because there also one source, right? If you are getting source from the dock station, here also adapter ID is coming. So where it's joining, see, this one is coming to the U23B. What it is? Here, this one is MEC 1653. This is IO. See, nowadays Lenovo manufacturing their own IOs, or it's handover. I mean, it's taken over with the MEC. Okay, this one is MEC IC 1653. Now it's a Lenovo ThinkPad, Think Engine. Okay, this one is Think Engine U23B IO. Now this AC DC in using this pull up, what it is, VCC 3M. Now you tell me, now AC DC one thing it has to be active, right? But using this, what are the IC should be active to know this AC DC ID? Now here is the one IC, what it is? Step down IC, correct. So it means 3 volts always, 5 volts always, 3 volts LDO, 5 volts LDO should be active. So now this one IC, what it is? Only step down is not enough, correct. This one is IO. IO also should be active. So here it means once you connect the adapter, here all of a sudden IO and step down IC will get active. Okay, let us see other ICs also active or not. Okay, now we got the IO and step down IC should be active. That concept you must know. Now again this one is gone. So again we will come to DC in section. Now you come to know ID, where it will go. It will go to IO using the pull up voltage of 3 volts always. Okay, this is clear. Now 4 and 3 both are combined and made as a dark power 20. Once you connect the adapter, the same power goes to dark power section also. Here it has given clearly it's a dark section. So now dark also active, one side. Okay, now this capacitor is there, it will charge, fully charged. After full charge again it will come to this fuse. In case of any unwanted distortions will be there, that goes to ground. Clear? So now it will come to fuse. This is special fuse actually. So if any malfunction happens here you won't get the continuity. Okay, in previously what are the motherboard were using, those all are continuity it was giving. But nowadays what are the ThinkPad using, those fuses won't give continuity. Means it's a depends on section where you are using that fuse. Okay, here if any issue will come, here it will be, the impedance will be more. Okay, if it is a less, then it's working perfectly. If it is a 0 completely, it will work perfectly. It means it will pass the voltage from here to here in case if there is no issue with this section. Okay, now what will happen, it will cross this fuse. So again where it has gone, here it has gone to Q107. What it is? PNP transistor. What it does, once voltage will come here, so it will enter here through this resistor. Here what is this? This is base voltage it will get. So once base voltage will get up to 3, it will come and it will stack here. So here what the logic, it depends on this MOSFET. So by seeing this we can't identify what voltage or what the next section will happen here. So that's why first here is the logic circuits. First we can understand the logic circuits, then only we come to know here we are getting voltage or not. Okay, so anyway you have to release the voltage. What is that? 20 volts, whatever it may be, that voltage will come here. But the main logic will start at the end. See, we have to come to the end part. Here one part is discharge and other part is minus power shutdown. Two signals are there. This is called signals. Okay, from where it's coming, that we need to check and what logic it will done. Okay, generally we will discuss in case these two will be low or high. So high means it's a 3.3 volts usually, low means it's a 0 volts. If high, this MOSFET will active. In case of low, this will be in off condition. Correct? That is the logic here. So now we will consider both are high. In that case, what will be the condition of this? That we will think. See, in case of this one is high, then what it will do? Here it will come, it will switch on. Q61 and Q78 both will on. It means what work it is? Just it will connect drain to source once on. So here it is connected to ground. Here it will connected to ground. This job completed. And one more, this one came. Okay, here the job is it will connect from here to here. It means what are the voltage will come, it goes to ground. That's it. It's a digital ground, not main analog ground. Analog ground it will get short. Okay, this is a digital ground. Temporarily it will be in short mode. Beep you will get. Okay, so now this ground, this up to here it's a ground. Up to here it's a ground. Okay, now you think about this. This voltage will come here. It will enter. Whatever the voltage will be there, that one goes to ground. It means it's a NPN channel, sorry, NPN transistor. What it does now, it's off, on or off, because there is no voltage here. Then it will be on condition because of the PNP, not NPN. Okay, it's a PNP. In case of PNP, the base voltage is 0, then it will be active, and then whatever the voltage comes in number 2, it will pass to number 3. It will connect, right? So then 19 volts will connected here. It will come here, it will come here, and here also same voltage will come here, it will come here, 19 volts, whichever is high voltage, that voltage will be available here, correct? It will come to this capacitor, it will charge, and again it will come to this, it will oppose after fully charged, again it will come, and here 19 volts will come to this P channel MOSFET. Now if you get the 19 volts in the gate, what will happen? It won't turn on. It will be in off condition. It means the voltage, what are the source voltage, it won't allow to the gate, drain, correct? So in case any voltage will be there in the gate, that one it will allow because of the forward direction. So now it's a reverse direction. In case of reverse direction, it should be on. When it will be on, that time only the that source voltage will pass to drain, but it should be on. But as per this logic, in case of these two will be I, then logic is wrong, correct? So the main logic here, the gate should be have some voltage, means lesser voltage compared to source voltage, correct? So it should be on position. In case of it should be on position, there should be a voltage divider. So first you have to think about voltage divider, how it will happen. Usually the P channel will come, the voltage divider should be there in any laptop, right? So you have seen multiple laptops, so voltage divider, how it will happen. First we will discuss from here, okay? Here is the resistor, and if we consider it is R1 and R2 not there here, so it will get sent here. So there will be no voltage divider. If we come to here, here is the one resistor and other also is there, but we can't consider it's a voltage divider because it's connected to here. Means it should be, R2 should be in destination part, should be in ground, but here there will be no ground, because in case of it is on, only it will connect to here. Again source it will connect. So one source and one destination should be there. Destination should be ground, source should be power supply. So now this case also wrong, and if we come to this, it will pass here, and here it's connected, and here also one resistor is connected, so here it won't be ground, so this possibility is also wrong. So then one more is there here, resistor, so here this should be ground. Is it possible or not, that we will check. See, here it's already grounded, right? So if both are high, this is already grounded. In case of this one is active, then this part also will get ground. So then here is the possibilities. So how gate voltage will come? Here and here. This one may be R1 or this one may be R2. So then we will consider this one as a voltage divider, correct? So that voltage divider will go here, and the voltage will pass from here to here. So then only we will get this further voltage. So now if this one should be active, right, then what will be the possibilities? In case it should be active, means it should get voltage because it's a NPN transistor. If it get voltage, then here it should be in off condition, correct? So the logic is here should be voltage and here should be no voltage, means it should be low and it should be high. In that condition, what will happen, we will check. Okay, now we will consider it as a low and this one is high. So in that condition, first we will come from the high. Here it will active, and what are the voltage, it goes to ground. So one is ground, this MOSFET work finished. Next it should be active. So for that, here will come, here is the low. In the case it will be in off condition, this also will be off condition. So now what are the voltage will be there, it will come to here. Voltage will come or not, we will check here. See, the main fuse voltage will come to through this resistor. So it came here, and here the NPN, what is that, transistor. In NPN transistors, if there is a voltage here, then it will be active condition, then what are the voltage will comes, it will connect to this, correct, emitter. Then here already emitter connected to the ground, so then this resistor destination part is the ground. So now here these two is off, right? So here what will happen, here what are the voltage will come, here it will get struck, and through this resistor here also will come, and but this one is in off condition. So that case PNP, here pin number 3 has voltage, in that condition it will be in off condition. So in that case up to 3, see up to here the voltage will come and stuck here. It means the main voltage will come to this resistor, and this resistor also it will cross this resistor, and again it will cross this resistor, this voltage will remains here. Which voltage here? Here is the voltage divider voltage. Okay, what are the voltage divider, you will get R1 and R2, that voltage comes and remains here only. In case any malfunction will come, then this one will get burned and it will protect the motherboard. Okay, that's for this PNP has used here. Okay, this one is for protection purpose, this logic. Okay, so now the voltage came here and here and here, it's already ground, the source is there, then we can consider it as a voltage divider. So now what will happen, here it came, and through this resistor it gone to this MOSFET. Now what we got, we already got after this fuse, this one we got, and here also we got pin number 5, I means it's a drain, also we got the main voltage. So what are the things we got now, till here it will come Q36, the source has this voltage, correct. So before this, now after this logic fulfilled, or before that, now we got this voltage, correct. This voltage where it will go and what it does, we will check. Here we have to paste it. So see, here one more fuse is there, F5. The main logic, the adapter, once you connect the adapter, this voltage, usually all motherboard it will detect, it will sense the main adapter is connected or not. For that reason it has taken here DC in power source. See, DC in, after this fuse, the fuse I already told you, no, once if any problem comes it won't active. So it will pass this voltage to here, and here diode, two directions are same, so same voltage will go here, which one is higher, that will goes to pin number 3. So it will become as a Vreg in 20. This is the voltage will go all over the motherboard, I think so, right? So okay, anyway we will check Vreg 20. So now through the adapter we got Vreg 20. Okay, and again where it will go, using the voltage, see this is charging IC, I think so, correct. BQ24780, it's a very famous IC. So a very successful IC also. So here AC detect work, see the main voltage is working as a voltage divider. So AC detect work, if voltage is there, then AC detect will sense and it gives the information to the charging IC, adapter is connected. If there is no voltage, then charging IC will sense there is no adapter. Okay, so now again where it has connected, that's it. So what we got, in brief I will tell you. First we got this one, it gone to where, dark station, and after this fuse we got this one, it gone to voltage divider in charging IC section. And one more thing, what it does, it became Vreg in, Vreg 20 something, right. So that also we got. So now we got the voltage here because of this logic. So what is the logic, here it should be low and it should be high. In that condition the MOSFET will allow the voltage. So now we will move on. See, here it will connect to here. Up to D13 this voltage will come and it won't pass because of the reverse direction of the diode. Okay, here it's a cutoff because these are protection ICs. Okay, this NPN or PNP transistor?
NPN.
Yes, NPN, and here is the diode. Diode is in reverse bias. So it will come to here. So we need not to worry about this. So it will come to here. What it is? It is
N-channel MOSFET.
N-channel MOSFET. Okay, N-channel MOSFET forward direction is there, so directly it will go to 5, and before that it has gone to here also. So here what it is doing? See, it will come to this through this 1 mega resistors, and again it will cross here, and again it will come to R22 R224 here. But the thing is, here some other voltage is coming here. This one from where it's coming, that we need to check. So we will copy this and we will paste it. So one more IC has to be generated, I mean active. See, DC in drive, what it is? It's a think engine. Okay, think engine page number 1 and page number 2 both are there. So it should be active. It means it's a power management IC. The think engine nowadays using this power management IC for drive purpose. You are getting 24 volts, right? It was coming through the IC. What IC? Charging IC. That AC drive. Okay. But nowadays this power management IC is controlling both battery side and as well as adapter side. The 25 volts. Before what we were discussing, first and second MOSFET should be high. That time discharging MOSFET should be low. That works was doing with the charging IC, the help of charging IC. But in this ThinkPad series, we are using the power management IC as a think engine. The name it is called think engine, but I also the name will be same, but this is power management IC. So this one will control all the sections, see, all drives. As a drive it will work. So necessary drives. Here is the output, it's a 10 volts output you will get. Here using 5 volts it will convert as a 10 volts. 10 volts. Here it's a LDO and LDO 5, LDO 3 and one more always also will get the input, and the main V int 20 that also will go to this power management IC. What it is mean V in 20, that we will discuss. We will come to know now. So it means one more IC, think engine, IO, step down, charging IC. These all should be active. First step down, 100% it should be active. Then only the voltage goes to IO and think engine, power management IC. Correct. So now along with once you connect the adapter, so these all should be active. Means it's a source. Now we are discussing the DC in source. After that we will discuss the battery source also. Okay. Now we confirm this DC in from where it's coming. It means it's a 24 volts should be there, because here the N-channel MOSFET. Here gate should be 25 or 24. It's a higher than the source. Correct. Then only it will pass complete voltage from here to here. So now what will happen? So here is the drive voltage will come from the think engine in case if it is on condition. Then it will pass the 100% voltage will pass from here to here. Okay. Then finally we got V INT 20, V in T20. It means it's a ThinkPad engine got the voltage from here. Correct. So think engine voltage, these are the after these are the circuits we will get V in 20. It means the main voltage will go to motherboard. Okay. So all over the motherboard. This is CLR. Now V in 20, where it will go, that we will discuss. But before that, this is the one source. Using DC in, we got V in 20. Correct. Using batteries, how we will get V in 20, that we will discuss. So this is the one source over. Second is, any doubt in this?
No, sir.
No, sir. No. Right? Okay. Now we'll go to main battery connection. So out of two battery, it's a main battery. We'll discuss with the main battery. Its a connection is J13. What are the pin it has? 1, 2, 3, so total 7 pins it has. 1 and 2 is the main battery voltage. Correct. This is main battery voltage. Where it will go? It will go to fuse. So fuse. After this fuse, it the named as MBAT power. What it will do? That also we need to think. See, here we have to paste it in. Here, MBAT power. MBAT power after the fuse, MBAT TRCL, and after this diode, V rage in 20. Now the DC in power made as a Vreg 20. One source came. In case adapter is not there, then main battery sides also it will generate as a Vreg in. Okay. So now Vreg in coming from the two sources. One is DC in and the other one is main battery. Okay. Now where it will go? That much only. So again we will come back to the battery section. So now other pin number 3, you know that very well, it's a clock, and fourth one is the data. No, it's a M temp. Fourth one is came here and it gone to data. Here 3 and 4 data and clock. So for this 100% 3 volts LDO should be active. Okay. So but here from where it has come, that we will check. See, it has gone to 58 page number and 70 page number. So practically we will check, directly we will check from where it is coming. Paste. Now here also it's going the same thing. It means it's a secondary battery. J13 is the primary and J35 is the secondary battery. So here also it's connecting, but from where it's coming, that we need to check. See, it's coming from this. The pull-up voltage is this one here. What it is? 3 volts always. 3 volts always is the pull-up for this clock and data. Now data and clock both are here. It's coming out from the battery section of the I/O. See, MEC 1653. Clear? So now the data and clock is coming from the I/O. It's a think engine I/O. So it's clear now. The battery section has data and clock. It will communicate through the I/O. So the main supply will come to the fuse, and after that it made here and Vreg 20 we got. Now after this, where it has come? It has come to the MOSFET. Here which MOSFET it is? N-channel MOSFET. VGS means what? Voltage in gate to source. Okay, it should be 25 volts. See, this is the source and this is the gate. So here gate should be 25 volts. See, M1 drive, all drive voltage, which one is giving? Think engine power management IC. Correct. So this is generally we will call it as a power management IC. So once you get the 25 volts, complete voltage will pass from here to here. That one will become power A, and after that it will come to Q34. Right, here it won't cross until unless you get the gate voltage. Correct, because it's a reverse bias. So now one more we got here, M temp. M temp is the output actually. See, through the pull up of 3 volts always. So this output where it's going, that also we'll check. This 58. See, here also 68. This one here it's a 58. From where it's coming, that we will check. It's a copy, paste. See, it's going to where? I/O. Battery section of the I/O. See, what are the section it contains? It contains data, clock, and it's information of the battery. Battery is connected or not. So that has gone to MEC. Means the information, once you connect the battery information, that directly goes to the battery section of the I/O. So one more also will be there, right? We have 2 batteries. So that may be S temp, secondary battery temperature, means it's connected or not, that information. Okay, now we come to know that I/O battery section will work. It will control these 2 batteries. Okay, the main voltage has to go to that CLR part, right? So T in 20 something. So that pass Vreg, no. So the Vreg will goes to again that CLR also. So now this main voltage, how it will become as a Vreg in. So now it passed from here to here. After once you get the drive voltage, it's a 25 volts. So once it comes, it will come here, and here P channel. Usually P channel MOSFET should get the voltage divider, correct? So voltage divider, we need to search the R1 and R2. So here if we consider it's R1 and if it is R2, then here M2 drive should be grounded. Once it ground, then only the voltage divider will happen and it will pass from here to here. Otherwise it will get stuck here. See, the main thing is it is controlled by power management IC. So that is very, very important. Here what it will happen, bat power 12. So where it's coming, here one voltage we generated, so where it will go, paste 1 and 2. See, the main battery power Q35, what it is actually, Q35, here also is there and here also is there. One more logic is there that we will discuss. See, okay, that we will discuss later. So here also the same voltage is becoming this one, correct? So there also it will generate. So now this voltage going to Q13. See, Q13 is very, very important MOSFET. You know why? Here is the answer actually. Here one more connection point is there. Now you are excited to know that part is here. See, bat power 12. This point is coming from this. What it is? Again you have to check this one. What it is? It's a secondary battery, right? So what are the secondary battery voltage that also coming through this and connecting to here, correct? It means we got both battery voltages here. It will combine here. Which one is higher than this? So that higher voltage will join here. So it means here is the common point to both battery. If you remove this battery is connected, then that battery voltage will come. If you connected this and you remove this battery voltage will goes here. And if you connect both, which one is higher, that voltage will go here. Okay, now you got it, right? So we come to know primary battery is controlled by the power management IC. So final result will come to here. But we didn't discuss that secondary. See, secondary also same thing. Once you connect this battery, here 1 and 2 connected, it's a secondary fuse. After this fuse, it will come to this battery and again it will come to this. It's a forward bias. Here gate voltage is controlled by the drive. Means it's a power management IC and again you will get the final voltage here and it will pass here using this voltage divider. It means S2 drive should be ground. When it will ground, that time voltage divider will happen, then this voltage will pass here. Then finally we get this. So like this, it's a common point is battery power 12. So after this what will happen, that we need to check. So usually we will check first second MOSFET from the primary side. Discharge MOSFET is the third MOSFET. So here Q13 is the discharging MOSFET. You know why? V unit 20 is the adapter side voltage. Okay. Usually in any laptops, any charging sections, first and second it will cross and after that CLR voltage will come. After that CLR voltage goes to discharge MOSFET, correct? So discharge MOSFET one side will be the 19 volts or 20 volts and other side should be what? Battery side. So battery side voltage here is the V unit is the CLR voltage. Got it? So here this functions, it's a depends on this battery drive. Battery drive is controlled by which one? It's a power management IC. Think engine power management IC. Correct. So once it goes to ground, then only battery voltage will pass here. In case battery drive is high, what it will do? It will be in off condition. Sorry, this one is N channel, right? In case of high, then battery voltage will pass here. In case of low, then it will be in off condition. So then this voltage won't go here. This also won't go here, because if it is an off condition, it's a depends on this. It's very very important thing. Once battery voltage will decide this one is on and off. In case of normal position, if there is no voltage here, then this voltage will pass easily. But here voltage will be there when you connected the adapter. In case if you are not connecting the adapter, that time battery voltage will pass here. What battery voltage? Battery 1 or battery 2? So both battery will connected here. This is as a normal one. Discharging MOSFET, it will act. So we need 20. From where it's coming, you have doubt, right? So already I told you, but again we will check from where it's coming. See, these all are CLRs one, right? It will go to all over the high MOSFET, all my high MOSFET it will go. So now we'll come to the charging IC section. 69. So DC in first and second, and here is the charging IC. See, this one is connected here, but here where it will go, it will come to this. Where it is DC in here. The output, sorry, here is the CLR. So what it is? V in T20. It means V in T20 is not only adapter voltage, as well as battery voltage also, in case of adapter is not connected. Okay, now you got it. Any doubt in this? Now first source is adapter, second one is primary battery, third is secondary battery. All three goes to this only, but concept is CLR concept. So one side maybe battery voltage will come, otherwise other side adapter voltage will come. But battery, even though it has 2 or 3 or multiple, whatever it may be, the only one voltage will come to the discharging MOSFET. Once discharging MOSFET is active, then it will come to the CLR side. Clear? If any doubt, you can ask. Now any doubt? No? Okay. Thank you very much.